Hello friends, welcome back to my YouTube channel. Today in this video we will discuss one very important numerical problem from projectile motion. This is also a most frequently asked numerical question. Now let us see the question. An object is dropped from the top of a tower of height 156.8 meter, and at the same time another object is thrown vertically upward with velocity 78.1 meter per second from the foot of the tower. When and where the objects meet? This is top of the tower. A be the top of the tower and C be the bottom of the tower. According to this question, height of this tower is 156.8 meter. A body is dropped from the top of the tower. At the same time another body is projected from the bottom of the tower. Let us consider they meet at the point B. Now we need to find when. When means the time taken by the body to travel from C to B will be same as the time taken for the body to travel from A to B. So B is the point where they meet, and we need to find the time when they meet, and where means what is the height or what is the distance traveled by the body from the top of the tower or bottom of the tower. That is the distance of AB or distance of BC. We need to find the time and the distance of AB or BC. Now let us see the solution part. Let A and C be the top and bottom of the tower, and B is the point where they meet. Also let AB be x, the height of AB be x, then height of BC will be automatically 156.8 minus x, because this is the total height. If upper part is x, then lower part must be 156.8 minus x. Now case 1, we have two cases. In case 1 we drop a body, we consider a body which is dropped from the top, and in another case we consider a body which is thrown up. In case 1, for the dropped object, our formula is s is equal to ut plus half at square, and we have already assumed that distance of AB is x, so s will be x, distance travel will be x, and initial velocity at this point is 0. U will be 0 because it is just dropped. So before dropping the initial velocity is 0, and then it is dropped towards C, towards the bottom, so acceleration due to gravity will be g, and t is square, so x is equal to half gt square is equation 1 for the dropped body, because u is 0 and s is equal to x. Now let us see for the projected body. When we project the body like this upward, in that case our initial velocity is 78.1 meter per second. With that velocity we project the body up, so our formula will be same, s is equal to ut plus half at square, but distance traveled by the projected body will be 156.8 minus x, because x is the distance traveled by the body from top, and 156.8 minus x is the distance traveled by the body from bottom. So distance travel will be 156.8 minus x, and u is already 78.1 into t, and in this case we are throwing up. If we are throwing our body up, then A will be minus g, acceleration due to gravity will be minus g, so our acceleration due to gravity will be our A will be minus g, so expression will be 156.8 minus x is equal to 78.1 t minus half gt square. According to equation 1, if we see equation 1, x is exactly equal to half gt square, so here we can replace this half gt square by x, and x are same, so we can cancel x here, and then 156.8 is equal to 78.1, so t will be 156.8 divided by 78.1, so t is equal to 2 seconds is the answer. After 2 seconds both body will meet at a point B. Now let us find the answer for the where. Our t is 2 seconds. Now substituting the value of t in equation 1, then we get our t is 2 seconds, and equation 1 is x is equal to half gt square, so our value for x will be 20 meter. That is the distance of AB is 20 meter. Then after after traveling 20-meter distance from A, the body will meet with each other. That is, if we calculate the same height from the bottom, then 156.8 minus x, that is 136.8 meter above the bottom of the tower. They will meet each other. So our answer could be 20 meter from the top or 136.8 meter from the bottom. They will meet with each other, and the required time period is 2 seconds. After 2 seconds, they will meet with each other. Thank you very much. Happy Vijayadashami to all.